Okay, so we're going to look at building a function, calling or invoking a function, returning function, and parameterized functions. So first off and foremost, let's actually forget about this main function. Actually, you know what? I'll leave it up open over there. We don't have to have anything in it for now. And let's write a function up here. And I'm going to comment that this is going to be building a function example. Function example. So in order to write a function, we bring in the fn keyword, instantiates the function, then we name our function. So let's say we just want to call this fn underscore function. You can name it whatever you want. Bring in the parentheses, okay? And then we have our curly brackets. We've done this a bunch, so hopefully this looks familiar. And we've also printed messages, right? So we can then, within the function, add instructions. We want this function to print in the console, hello, I am a function, right? Okay. So we know we can bring in this string, and if I hit run and we run the code, we're going to get this unexpected closing delimiter because, oops, I have an extra parenthesis there. Sorry, not parenthesis, curly bracket. I want to show you something. We're going to check the standard output. What do we see? Well, we see nothing. We see nothing. And why is that? Did we do something wrong? No, we haven't done anything wrong. Remember, all we've done so far is build the function. All right, that's the first part. What we want to do with this function is actually call or invoke it, because if we don't call it, it'll just remain. The function will sit there in the global memory till we call it. When we call it, then we're going to access what's inside of it, etc. That can change things. We're not going to get too deep, but the main point here is that this is building a function. All right, so that takes us to the second one. Calling or invoking a function. A function must be called so as to execute it. So if I go into the main function and I run the function, I execute the function, I invoke by bringing in the parentheses and stating the function. And then these parentheses right there, let me make that bigger. These parentheses right here is calling this function, and this function has this instruction, and the main function is going to be automatically executed by the compiler. So let's run it now and check our output. Hello, I am a function. Now the function is being invoked, and that is how we call a function. All right, number two. Number three, returning functions. Now, functions may also return value back to the caller. Okay, now how does that really work? Okay, what do we mean by that? So let me actually just comment invoking the fn underscore. And I'm going to actually write this above the main function here. We're going to comment this in, and we're going to say some functions can have return statements that return value back to the caller. Okay, so let's call this a function return. Now, when we want to return explicitly something in our function, we have to statically set in our signature what the data type we want to be outputting. That with a line and arrow, and then we specify. So let's say we want to return a true or false value. What kind of data type is that? It's a Boolean. So we could actually write bool for Boolean, then bring in our curly brackets. And if we want to return, let's say this function returns true, we would just write return true. Okay? And this is what a return statement would look like in a function. And so this function is going to carry out whatever tasks, but what it actually is going to output and return back to the caller here is this true value, this truth value. Okay? So it's returning functions. So we notice we're always using these parentheses, but we don't often put anything in them. Well, these parentheses can actually take parameters which you can use as arguments. Now, what do I mean by that? So what I'm going to do is I'm going to write another function, and I'm going to call this, actually here, let me do parameterized function example. I'm going to write a function, and I'm going to call this, I don't know, another function, okay? I don't have any good ideas. Another function, all right? This function is going to print an argument. So it's going to say the value of x, all right? And we're going to put x. Now we could write x inside the function and set it to some value. But what we want to do, oops, not parameterized, parameterized, I think. Yeah, okay. Okay. So we could put x here as like a value, as a variable, but we want to instead actually add x to be a parameter. And boy, this is powerful stuff. I'll show you why. So we can put x over here. Let's say we want x to be an integer. So we're going to say x I32. And the value of x, just be a little bit more grammatically coherent. The value of x is, okay. And so now we have a function that takes a parameter. Why does that matter? Why is that so relevant or interesting? If we go into our main function now, and we run another function, not only can we call it, we now have access to this parameter. We've created an argument. And this parameter can take any signed integer of 32 bits. I can actually put 100 in here. And if I put 100 in here, and we run the compiler, we see the value of x is 100. The value of x is 100. If I change 100 to 10,000, and I run the function, we see the value of x is 10,000. So hopefully you see the power in this. The power is that now we have this dynamic ability to actually use this function to change and manipulate data depending on what we want to input into the function. And these things, okay, parameterized functions, invoking them, building them, and return statements, these are the fundamentals for functions, the functionamentals. Puns aside, that's how you write functions in Rust. Let's stop here and run through an exercise together in the next lesson so you can try writing out some functions of your own and have function doing it or something. Nah, not so good. No more puns. Okay, I'll see you in the next lesson.